Welcome back. Today we're talking about using exponential and logarithmic growth. So that means we're going to be using word problems the whole time. Very exciting. So let's get right to it. So we're going to be talking about exponential growth and decay. When we talk about these, we're talking about continuous growth. So it has continuous right there, continuous growth and continuous decay. We're not talking about your average growth or your average decay. It's going to have the word continuous in it. Or if it doesn't have the word continuous in it, it's going to be a continuous implied. Kind of like if we're talking about something that's radioactive or something like that, and it's decaying, that's going to be a continuous decay because it always decays little by little by little. Sort of like bacteria. Bacteria also have a continuous growth because all of the bacteria, they're always reproducing. So that's why they're telling us it's a continuous growth. So when that happens, that's when we're going to use exponential. Notice that when we have an exponential growth or an exponential decay, we have a little bit of a new formula. And it's going to be y equals ae to the kt. Or ae to the negative kt. The only difference is that in exponential growth, our rate is positive. So that's why it's positive kt. And when we have exponential decay, our rate is going to be negative. And that's why it's negative kt. Our a value is going to be our initial amount, the amount that we start with. T is going to be our time in years. And k is our growth rate or our decay rate. So here's an equation, or here's a problem. I have sodium 22 and it has a half-life. As soon as you see the word half-life, that's one of the cues that you know that it's going to be a exponential decay because it's half-life. Each time you're doing it, it has half of what it had before. So we have sodium 22 is 2.6 years. That's the half-life. We want to determine the value of K and the equation of decay for that particular mineral or whatever it's called. So if A is the initial amount, I don't know what the initial amount is. We started with some amount, but it doesn't tell me that in the problem. So I know, geez, everything keeps popping up now. It doesn't tell me what the initial value was, but I know that I end with half of what I started with. That's what the half-life means. So I'm going to say that it starts with a value of A. So there's my amount. I don't know what it is, but I'm going to call it A. I know that I end up with half of what I ended up with. So that's why it's half of A. So for instance, if I started with 6, I would have half of 6, which would be 3. But since I start with A, I'm going to have half of A. So from there, I'm just going to solve the equation. So I'm going to get the like terms together. So I'm going to divide both sides by A. So when I divide both sides by A, the A's just cancel out. So I'm left with 0.5 equals e to the negative 2.6k. Well, again, we want to solve that equation. In order to solve the equation, we're going to have to get rid of the exponent that's up here. Since I have a base e, that tells me that I'm going to want to take the natural log of both sides. So that's exactly what we're going to do. So if I take the natural logs of both sides, I would have ln of 0.5 equals ln of e to the negative 2.6. Well, since I have the log base e of e, that tells me that that's going to cancel out, and that's just going to be 1. So I have the natural log of 0.5 equals negative 2.6k. I need to get the k by itself because that's what we're solving for. So I'm going to divide both sides by negative 2.6. When I divide both sides by negative 2.6, I get the natural log of 0.5 over negative 2.6 equals k. And then I can use my calculator and I get 0.2666 is approximately what k is. If they asked for the actual rate itself, then generally speaking, you can turn that into a percentage and make it 26.67%. Or if they just ask you to use the k to put it into an equation or something, you would leave it as the 2.2666 so that you can put it back in, because when you use it, it's got to be in decimal form anyways. So that's how you find k in an equation. Then the follow-up for that, it says in a new problem, I'm still talking about sodium 22, and it says that a geologist is examining a meteorite and it has 10% as much as it would have had contained when it was reached the Earth's surface. How long ago did the meteorite reach the surface? Well, this time they don't tell me how much I started with. I just know that there's 10% of what there was before, and I don't know what the T is. But I also know what K is because I found K in that last problem. So since we're still talking about sodium 22, our rate of decay is going to be the same in the last problem as it is in this problem. So sometimes when you see problems like this, they would be put together. So you would start with the first problem and then like part B to that same question would be this problem. So they're kind of like linked together. So I need to be able to solve. So what I'm going to do is I'm going to create my equation. This time, I still don't know what I'm starting with. I'm starting with an amount. So that's like A. I know it's going to be left with 10% of what I started with. So if it's 10%, I would change that 10% into a decimal, which would make it 0.1. So I would have 0.1 of A. So that's what my Y value is going to be, or my f of x. So that's going to be 0.1A equals A e to the negative k, and we're going to call it negative because it's decreasing. So that's negative 0.2666 and then times t. So this is what it would look like if I write it as an equation. So then I need to divide both sides to solve. So I'm going to divide both sides by a. So those a's are going to cancel out. So now after you've divided the a on both sides, I'm left with 0.1 equals e to the negative 0.2666t. Again, we need to solve for t. So in order to solve, since it's in our exponent, we're going to take the natural log of both sides since I have an e in my equation. So I have natural log of 0.1 equals the natural log of e to the negative 0.2666t. Since I have the natural log of e, that just cancels out to be a 1. So I'm left with the natural log of 0.1 equals negative 0.2666t. And then I can divide both sides by negative 0.26666. And then I can use my calculator, and I get 8.64 is going to be our years, and we'll round that to 2 decimal places to find the number of years. And that will be all I need to do for that one. Now, I need to make sure that it actually works. So I'm going to substitute it back in to make sure that that is a true statement and I don't have any negative logs. So when I substitute it back in, I can see that I would put in original amount of 1. We don't know exactly what it was, but we're going to assume that it was 1. And then I'm going to put in the 8.6. When I put in the 8.6, I end up with the amount that I have left, which is 0.10, which is roughly 10% of what I started with. So it ends up that it does work and everything's good. So here's another one. This time we're talking about population. Obviously, if we're talking about population, we're talking about a population growth because almost everything is growing when we talk about population. And we're talking about population, so it's continuous. In 2007, the population of China was 1.32 billion. In 2000, it was 1.26 billion. We want to determine the value of k to find the rate at which it's growing. So since the earliest year that's in our equation, or in our problem, is 2000, 2000's population is going to be our initial amount. So our initial amount is going to be 1.26. So I'm going to substitute that in for a. I have to find out what k is, so I'm going to put in the population that they gave me in 2007, and that's going to be our y, or f of x value. So that's going to be 1.32. Between 2000 and 2007, there were 7 years, so that tells me that t is going to be 7, and I have to solve for k. So I'm going to divide both sides by 1.26 so I can get the e by itself. So I get 1.32 divided by 1.26. And if you can, it's best to try to hold on to that and don't actually do the division. And we'll do the division in just a little bit. But if you wait to the very end to do all of it, it gives you a better answer. So from there, we need to get the exponent. So since I need to get the exponent, I'm going to take the natural log of both sides. So when I take the natural log of both sides, it looks like that. And then again, I have the natural log base e of e, which cancels out. So I get 7k equals the natural log of 1.32 over 1.26. I want to get k by itself, so I'm going to divide both sides by 7. See how we waited until we got to the very end, until we used our calculator? That's going to allow us to keep all of those decimals that go really, really long into our problem, hold it all until the end so that we don't have to worry about rounding so much. So now you're going to do the natural log of 1.32 divided by 1.26. Notice that you're not taking the natural log of 1.32 and the natural log of 1.26. You're taking the natural log of parentheses 1.32 divided by 1.26, close parentheses. And then you're going to divide that by 7. So when you do that, we get 0.0066, which tells me if I were to change that into a percent, it would be 0.66%. And that's what they asked for, was our growth rate. So that tells me that I would have 0.66%. And again, just like before, there would probably be a follow-up question to that. So here's my follow-up question. So they tell me, again, it was 2007 to get the 1.32, and in 2000 it was 1.26. They give me that information so that way you know that the data that I had in the last problem corresponds with the data that I have in this problem. If it were different data, then that would tell me that I would need to go back and solve for a different k value. Since the data is the same, I don't need to solve for k again because I had already solved for it, and it would be kind of silly to do it again. So now it asks, when will the population reach 1.5 billion? So 1.5 billion was the population, so that tells me I'm going to put that in for y, or f of x. So if I put 1.5 in, now I know that my k value was 0.0066. Remember, we're going to put it in as a decimal. I have to solve for t this time. So again, I'm going to get the e by itself first, so I'm going to divide both sides by 1.26. And again, they divided here, you want to wait till the very end. So I have 1.5 divided by 1.26. I'm going to take the natural log of both sides. So when I take the natural log of both sides, I would end up with the natural log of 1.5 divided by the 1.26. And then I would have e to the 0.66. And I would then take the natural log of both sides. So that's going to cancel out and become 1. So I have here, and again, I don't particularly care for them doing that. I would rather you leave it as the natural log of 1.5 divided by the natural log, or divided by 1.26, and wait until the very end to actually do that math. And then you're going to have the natural log of 1.5 divided by 1.26 divided by 0.0066, which would be 26.420. And when you get that, you would see that it would be rounding it to 26 years. So if it's 26 years and I started in 2000, that means in the year 2026, then they would end up with the population of 1.5 billion. So coming up pretty close. Anyways, hopefully you'll be able to try some of these problems. I'll have some for you to practice, and of course, obviously, we'll be doing lots more word problems when I see you next time in class. So have a good night, and I'll see you next time.